Imagine a particle that is its own antimatter twin, a ghostly quantum entity that could revolutionize computing and physics. This isn't science fiction, it's the enigma of Majorana Fermions. But what exactly are they, and why do scientists believe they could unlock the future of quantum technology? To understand this, we need to go back to 1937, when Italian physicist Ettore Majorana proposed the existence of these strange particles, and then, mysteriously, disappeared. In simple terms, all particles in the universe have an opposite counterpart. Matter has antimatter. But Majorana fermions are unique because they are both at the same time. Unlike electrons or protons, they don't have a distinct opposite. Instead, they annihilate themselves under specific conditions. But where do we find them? So far, scientists haven't detected them freely in nature, but they may emerge in superconductors, special materials that conduct electricity with zero resistance. Okay, so why do we care about these weird particles? The answer is quantum computing. Majorana fermions could be used to build topological qubits, which are far more stable than regular quantum bits. This could mean faster computing power, unhackable encryption, new breakthroughs in physics. Today's quantum computers struggle with errors. Majorana-based qubits could fix that problem, bringing us closer to real-world quantum machines. But there's another mystery. The man behind the theory, Ettore Majorana, vanished without a trace in 1938. Some say he ran away, others believe he was kidnapped, and some even think he discovered something too dangerous to be revealed. His disappearance remains unsolved to this day, but his ideas continue to shape modern physics. So, what do you think? Could Majorana fermions be the missing key to the future of quantum computing? And what really happened to Ettore Majorana? Like, subscribe, and hit the bell icon for more deep science videos. Drop a comment below. Do you belie?